We are going to talk about something very, very, very exciting. It's called extracting entities and relations in Portuguese documents. Okay, so a bit of our outline, it's meet our team. Introduction, a natural language processing overview, NLP setbacks, our solution, our study case, and our results. So, what is AI? There is no technology called AI. AI is a constellation of technologies that allow machines and systems to sense, comprehend, and act and learn. So you can see like the traits of human intelligence, sense, comprehend, act and learn, and we have AI components like computer vision, audio processing, natural language, knowledge representation, expert systems, machine and deep learning. As a result, we have virtual agents, cognitive robotics, identity analytics, and so on. So this is a bit of our team. By the way, it's an exciting and amazing team. So it's a number of people according to the education of our team, the artificial intelligence team, by the way. The number of people like with graduate degree, Masters of Science, PhD, and so on. So we can see here that we have some kinds of skills. We have people working towards computer vision, machine learning, deep learning, natural language processing, inference engine, virtual agent, and so on. Okay, so the main idea of this talk is how can we extract important information from documents? We know that analyzing text document is a time-consuming and repetitive task. So how can we extract relevant information from that automatically? Feature engineering, annotation, extracting words. What else? Like, we know that documents are mostly written by humans. So we have human language, and this means natural language. So we know that natural language, it's something tricky, like it's not just words or extracting words. They have some kind of meaning, and sometimes they are ambiguous, like one sentence can mean two different things. So how can we deal with that?
So let's talk about a little bit about human language and natural language processing. So natural language processing is a big area, basically divided in two main tasks. Natural language understanding, these are the main tasks here, and natural language generation, chatbots, translation, speech to text, and other things. But we will not cover natural language generation here. So basically, understanding is important. Why? I don't know if you notice, we speak natural language. Portuguese is a natural language. English is a natural language. Spanish and other kind of natural languages. So it's hard to understand what everyone is trying to say. So we need to construct and try to understand these. Basically, because of natural language have these characteristics, that is ambiguity and compositionality. So why not simply use a regex expression to extract all these things? Because ambiguity and compositionality. I don't know if you notice, but regex is just a regular language. It's basically a graph with a directional graph, and you can't capture ambiguity and you only can capture dependence graphs. So the idea is to use a probabilistic model to capture and fix this ambiguity. So parts of speech tagging. Do you have a thing here? Here. Parts of speech tagging can be understood as this level. So this level and this level. So you can, the basic idea of the task is to, given words, you extract each tag, corresponding tag. So if this word is a verb, it's a subject, or going on. So the output of your model will be something like that, okay? So why part of speech tagging is important? To extract relevant features or deep features, linguistic deep features from texts and everything. Something very important is statistical parsing. Parsing is probably the most important task in natural language understanding because you can construct these compositionalities here. You can compose chunks or just simple words and combine into a compositional function to get a class, okay? And using these two basic tasks, you can extract very important and relevant features to try to reduce ambiguity, to classify documents or whatever you want. So name entity recognition is a very cool task. Shares some language irregularities with parts of speech tagging because the idea is very simple. It's basically the same. You have the input words and the output is not a morphosyntactic category, but like, for example, São Paulo. You want to difference the difference between São Paulo, the city, and São Paulo, the football club. So if you want to do that, name entity recognition is probably what you want. So you can use features extracted from these two levels to feed a model in entity recognition. So another tasks or representations are word embedding. Entity link recognition is a very interesting area that combine entities and try to relate with other entities using probabilistic models also. And of course, text classification, which is more known task here. These two are two types of outputs from statistical parser, but I don't have time here to cover everything. So let's go. So what is the problem? You know there is ambiguity, and there is other thing, that data sets, right? How to construct very interesting models and powerful models using deep learning or machine learning because if we don't have any meaningful or represented data sets that represent that type of ambiguities. So, so Portuguese, there is that problem, and on top of that, there is a very interesting paper from 2013 talking about morphological richness languages that are languages that have they are difficult languages or maybe more ambiguous than others. Why Portuguese is a morphological richness rich language? Because basically because we have some more verbal classes than other languages like English, for example. So we have some intrinsic problems. So we have more compositionality maybe than other languages. So, and the problem in NLP, if you're gonna try to construct something, construct some classifier or something, gonna be the most of the resources are available on English. So The other problems that we fronted on our application was we have some documents on only image and we have to translate that. You have to use some other type of techniques to deal with that, like OCR. And other problems are when you try to classify something in academia, you have a very well-defined data set and work very well and everything is beautiful. So when you're going to apply that, you're going to have some problems because the domains are different. So you need to try to create this data set, so try to transfer some knowledge from a specific domain to another. So.
Okay, so having this problem, we came up with a pipeline. Okay, so most of the documents, not most, but in some cases, the documents, they are not very readable for algorithms first. They are images. So we just use OCR from Google Vision. It seems to work well. Yeah, for our point of view. So after that, we need the pause tagging. That this task will give us the part of speech tag from every word. It's important for us to build features at this point because we need to understand the language. Language has some kind of structure in Portuguese, for instance, like the verb and noun. And we use these features to go to the next text. We use name entity recognition. We use conditional random field algorithm. So we use, in our case, we use a scikit-learn, to do that. And it's important for us because we can see a document and we can annotate the important information we want the algorithm, once trained, to extract. So it's important. So once we have the entities we want, like names, addresses, or numbers, or ID identification, or something like that, we have to relate them. Because sometimes in documents, some things have relation to others. For instance, someone is, I don't know, like the mother and the daughter, and maybe the text can give us this information. And when you use convolutional neural networks, we can do that. So at this point, we have entities and we can relate the entities. So we use word embeddings for our CNN sometimes, and sometimes not all the cases. But if we have like some important information that we extracted, but we have to relate to a given list of sentences or something like that, we use word embeddings to relate them semantically. That's the word embeddings are very, very good for this case, as Pablo stated. Okay, so okay, so we had our case. We were coming up with this pipeline because we had something to do, like we have a study case. So we had something called letters of attorney, that in Portuguese are procurações física e jurídica, and articles of incorporation, contrato social. We did some research on the internet to make sure that there was the terms to be translated for English, because like we are dealing with Portuguese documents. So we wanted to extract information from those documents, like the name identification, the CPF, the Social Security number identification. We had to identify the powers of attorney. Like someone gives a power to open account or to represent someone in some place or something specific. Once we had entities, we wanted to understand was given power to another, because we can identify in the text names of people, but we are not sure who is going to give power to someone. It's important. And once we have the entity linking task, we can identify that. In this case, in the Portuguese document, it's called outorgante and outorgado. After that, we had the powers. Someone can open bank accounts or something. And we had to compare semantically those powers to a given list, you know, because sometimes opening a bank account, it's not exactly this way that is in the document, because the documents, unfortunately, a lot of documents from letters of attorney, they don't have much, they are not they don't have many patterns. Sometimes they are very different from each other, so it's a difficult task. So this, first of all, this is not a real document. This is totally made up, okay? It's just a sample. We created this data based on a library, okay? So it's not real information. It's just an illustration. So we have this, and we can see that our, this is a procuração jurídica. It's for a company. So we have to identify who is the company, where is the CNPJ from the company. We identify 2 names in this document, and we identify 2 CPFs. But at this point, we don't know exactly who is given power to another. And if the first CPF is the first person, or the second CPF is the second person, we don't know. So once we do the relation task from this convolutional neural network, we can identify who is given power to another, or who, like, first CPF is the first person, or it's not. It's important because we just don't want only to identify the people or numbers. We want to understand what the document is saying to us. Okay, so what happened when we did that? We found out that OCR depends on data quality, because some images that we had were not very good. They were blurred, and we know that OCR, it's not perfect. We had some problems, like the data and sometimes the OCR was understanding Portuguese names and Russian names. It was kind of weird, but it happened because of the quality. We understood that articles of incorporation are complex types of documents, because sometimes some names, they appear in the document more than once, and this is a problem for the CRF. What else? Solution works well for Portuguese. We had some kind of F-score like 80% in the articles of incorporation. A small application was able to relate letters of attorney and articles of incorporation documents regarding powers. In this case, once you have like the company for the letter of attorney for a company, you have to make sure that the person who is given power to another in that document is the same that has this power in the article of incorporation, because that's a company. You have rules. You can do just something that you want. You have to make sure that. So our tasks can solve this problem. And the last one, annotation, is very, very important, because we started annotating documents and we created some kind of rules, but it wasn't sometimes like we are running and training, and it wasn't that good. So once we started seeing the annotations, they were not standard, and it was, no, we have to change that. We have to align again, and see that annotation. It's very, very important. So that's all. Like this work was made in collaboration, like me, Pablo, and Renata over there. And the post tag that we used was developed by Pablo. Okay, it's a very good one, by the way. And just one more thing, wait for it. We are hiring. Okay, thank you, everyone.
Questions? How many documents did you have to train the model?
Can you guess it? Very, very short, like very few documents, like about 1,000, like it's not many. Yeah, we had to do some kind of magic over there because we didn't have many documents. Yeah.
Did you try any augmentation techniques?
We have tried. But it didn't go very well because letters of attorney, they are as we said, we think that they have some kind of pattern, but they don't. So we try to create randomly the information based on some kind of samples, but it didn't seem to.
The problem is language is hard because, you know, language is this kind of recursive language. So natural language is this type of language. So it's very hard to capture this type of things. So instead of augmentation, I would say annotation because you need this type of information to be precise on your data sets to really increase your scores. Okay, but not augmentation. Never use that.
More questions? Thank you.